and design robots that don't necessarily have to be built, and you're not wasting any money on them and that type of stuff. You still want to play within constraints, so does Swerve actually help you? Swerve is a drivetrain that's really complex. It uses a lot of motors to actually steer the wheels, and it's very complicated. Most of even the best teams in the world have backed off from doing it because it's just not worth it most of the time. Okay. Any other questions about the specifications and ranking them and that kind of stuff?
So sometimes it just depends on the competition of whether or not it's easier to do the end game or just try to score regular.
Right. It's all to how your team does the analysis and partly how you're going to be doing prototyping of the different designs. So even if you end up saying, we really like the idea of lifting 2 robots up and that's what we want to build, but once you get to the step where you're doing prototyping and you figure out you can't build that, you may have to go back to the drawing board and say, okay, so this was way harder than we thought. That cost benefit isn't worth it. It's going to take too much time, too much resources. We may fail. The risk is too high. Let's go back and do something simpler, even though we wish we could do that. And some games don't even have end games. So the 2014 game, there wasn't an end game specifically. There weren't any other points. You really only could get assists and throw the ball through. There were other things you could do in the game to help your alliance, the goalie pull and things like that, but you weren't necessarily a specific end game. People who weren't in FRC last year, one of the big trends through build season was everyone thought they were going to release a secret end game because the games didn't have one and every other game prior had. But there was not a secret end game. Okay. All right, so now step 4, which we're not looking at on the screen because we're doing. There we go. All right, step 4 is generating ideas. Some of you have already started this step. That's okay, like I said, steps blend a lot. So it's very hard to necessarily talk about specifications without talking about how you think you're going to implement them. But in general, you want to. In this way, we're basically just saying the what of how we're going to actually accomplish all those tasks, right? What is the robot going to look like? Is it going to have, you're assuming it's going to have wheels probably to move around. I don't think anybody mentioned a walking robot. Probably is not going to give you much in this game. No reason you couldn't. So a lot of this step is what we basically consider the real hard brainstorming aspect of it. How, they don't really have to be, you don't want to get to the point of like what material you're going to be using and how you're going to produce it, right? You don't need where the holes get drilled. But you need to have, okay, so we're grabbing this inner tube. What are the different ways we can grab an inner tube? We're lifting other robots or we want them up 12 inches. What are the different ways we can do that? This is the step where you want to basically throw everything at the wall. There's no wrong answer. Put it out there. Worst case, you don't build it, right? It doesn't harm anybody. Hopefully it'll spark somebody else's creativity into something that's really cool. The other reason you want to do that is almost guaranteed some design that somebody on your team thought up that you thought was crazy, some other team is just going to run with and absolutely love and build. And it may work for them, it may fail for them either way, but it's nice to already have it planned for. Sometimes you may need to plan a defense for it, depending on what you're doing. So getting every single idea against the wall that could possibly happen with a robot. There are tons of ways to play this game. There are probably tons of different ways that people in 2007 didn't even play that you could come and think of that maybe weren't able to be implemented, but it's still a reasonable thing to think through and walk through and kind of just throw out the wall. So just take a piece of paper, start generating, blowing out ideas. The other thing to look at, and one of the things we're going to get, you don't necessarily have to do a lot today because not everybody has devices or anything, but when you're doing this step during build season is to do some historical review. We're actually going to do, I have quite a few slides on it, in how teams do this for other games, but the biggest thing that you can do is FRC is a very, very specific thing that we do. We build robots to compete in these games. So it's the only really hardcore, solid examples of them are other FRC robots. So a lot of times you want to go, if I'm building a drivetrain, I'm not going to go look at my Toyota or whatever and go, that's the drivetrain I want to build. No, you're going to go back and find a really good FRC robot and learn from that one and copy from that one. So the more robots you can watch, the more match videos you can watch and have people explain their robot to you, and there's videos of people explaining their robots and how they do it, and presentations and all of that stuff, the better you're going to be at building FRC robots because they've built good FRC robots. It's a pretty small subset of people who do it. About 2,800 groups of people in the world who do it. That's a really small number, and most of them are really nice, and they'll answer questions for you. Like, they're pretty much every year I go, that robot a while ago was really cool. Let me send an email to somebody who built it and find out how it works. Like I get one of the ones for HOT in 2010. Like I literally was like, I don't know how that worked. And I sent the guy an email and he made me a presentation and sent it back. Like that's how nice these people are. Like they will do crazy things to help you understand how their robots work. So feel free to look around and look at other games. 2005 is a reasonable game to look at for how ARMs work. It was another ARM game. People, if anybody was here at Mock Kickoff 2 years ago, we did the 2005 game. I have no idea if anyone was actually at that one. But yeah, feel free to do that. Start generating tons of ideas, getting them out there. Don't look too much at the 2007 robots. We're going to go through some of them together and what people actually built. But if you come across them, there's no real rules against it. But don't just copy someone else's idea. The idea is that you're hopefully generating the ideas with your group. Questions? Good? Oh.
This isn't so much a question. Your last statement, steal from the best and then invent the rest. You're advocating copying, and that's really good. You must understand
Correct.
What you're copying.
Right. Right. So you definitely have to get to the point where you have an idea of what's actually happening, how it's working. That's why I was saying, if you like some idea from a team and during build season, or preferably before, because people are busy during build season building robots. But if you have an idea or you like some robot, shoot them an email, figure out a way to get contact them, talk to them at the event, understand how they're actually building those robots, how they're doing it. And they'll do a lot to help you. I mean, I do this, we get emails on our team from people who are like, how does your robot do blah, blah, blah. Just last week, somebody in Israel was asking us how our drivetrain worked from this year, and we were talking back and forth on how it works. So yeah, feel free to do that to teams all over. Most of the teams are really, really helpful, and they can give you a really good understanding of how their robots work. All right, so start brainstorming. Let me know if you have questions. All right, everybody. Come to it. I have it timed. People are still working just because you weren't Abersec. Okay. All right. Hopefully everybody's pretty much through brainstorming. Okay. Logistics stuff. Pizza's on its way. It should be here soon. Okay. Yeah, that's where the lunch slide comes in, but we're not quite there yet. Okay, so do people want to, boys, we're moving into lunch. Basically want to talk about what people, ideas that they're throwing out there, what they think robots can be. People have drawings they want to show, talk about ideas, that kind of thing. We probably have about 15 minutes or so. Anybody, any takers? Really? No one likes their robot? Come on. Do you want to draw or talk, or how do you want to do it? Talk? Okay. All right, everybody listen up.
So for ours, we're basically having a long and thin ramp that two other robots could come onto, and it's lifted by 4 scissor lifts so that it can get 1 foot off the ground during the end game.
Okay. All right, and so right now, thank you very much for sharing. So like I said, a lot of them can just be ideas. You don't have to have a final decision right now by any means. You're throwing out different random things.
So we use an elevator to pick up or lift the tubes, and we have these things that we call wings. They're not to fly, but they're to help us lift 2 other robots onto, or they're like 2 ramps that come down. And,
yeah.
other robots.
That makes sense. Yeah, lots of robots will have wings. Our robot had wings. We don't actually fly with them. Something else wanted to share?
We had the same idea.
Oh. Okay, so part of the goal should be to have hopefully many ideas on how you're going to do it. So if you have, if you're lifting things, you want to be able to have tons of different ways to lift other robots. Like scissor lifts are one way. Teams tried that. Some teams had success. Some teams failed. Teams have different sort of ramp ideas. We'll go through some of the more unique ones after lunch as we go through some of the 07 robots and how teams actually implemented the ideas. But your goal during the brainstorming process should basically be to hit every idea to where no one comes up with something that you haven't at least kind of thrown out there. You don't have to have a full design for anything, but you want to have everything against the wall. You want to make sure that you have some idea of something just so you're not missing that one really great idea. I know a lot of people in the 2014 game, a lot of people kind of just dismissed how the eventual world champ ended up playing the game.
So how did they?
The wheeled shooter. So not a lot of people had a wheeled shooter. We can show the video of it in a little bit. when we talk about robots. But basically, most teams had some sort of catapult where they were throwing the ball. It seemed to make a lot of sense. But the Cheesy Poofs, one of the teams we've looked at their score for because they won the 07 game too. No, sorry, they didn't. They were on 11, which is what we're going to look at later. Their robot did something very different from everybody else. And that was because when they were looking through the brainstorming part of it, they didn't get rid of any of their ideas too quickly. So at this step, in the step 4 phase, right, again, we're doing this very differently. We're not actually having to build it. But right now, you're not necessarily want to be, it's very easy to start, getting attached to a design. This is my design, or this is our design, this is what we're going with. But until you really have prototyped them, and until you've really looked through them, you shouldn't say, this is our design. This is one of the designs we might go with. This is one way we could go. But if you can really, you want to have different people in your team having different designs is great. You don't want everybody to be at a consensus really early, because otherwise you're going to miss something that may be really good. So last year we had somebody working on some version of a wheeled shooter. It was never quite Cheesy Poofs, otherwise we would have probably built it. But we had wheels shooting balls trying to do it, and they never worked very well. But they managed to get it to work extremely well. So that was because they had people doing different things throughout the season. So they had people building catapults, they had people building wheeled shooters, trying them out and figuring out what was actually the best idea. They knew what their specs were, they knew what they wanted to be able to do, and then they brainstormed and then built prototypes to be able to get to meet those specs. And that's why we're doing it in this order. So we're not saying, this is the robot we're building right now. We know that. This is what we would do. You want to say, these are many of the robots we could be building, all the different ones we could be building. Now let's actually test them and see which is the best. Anybody else want to share robots? Anybody draw pictures, have crazy ideas? Again, brainstorming, nothing's a bad idea. Really, nobody had things that they think are bad ideas? Yeah, there we go.
We had a cat that was a static in charge of electricity to pick up the tubes.
Okay. So live animals is probably a bad idea in robots. I don't.
But it's brainstorming.
It is. I'm just saying. I think that might be within some of the. You don't want buckets of red paint on your robot. Not good. Okay. Other ideas that actually happen? Probably, yeah, not reasonable. Okay. Other reasonable ideas to play the game? Anything somebody thought was cool? Guys, shh. Everybody back up here. Come on. Okay. Everybody, shh. Okay. Anybody else have other ideas? I should assume not everybody focused on the same plan and only had one idea. If we have 50 people in the room and we came to one idea, something's wrong.
I have more of a strategy, but basically what you would do is instead of trying to score, it's
Everybody, so we have somebody talking, please. Can we listen to him? Thank you.
There's no rule against hitting the rack, so basically you just shake the rack the entire match, so it's really hard for anybody to get a tube actually on the rack. Because it doesn't say you can't do that, so you can just go back and forth and shake the rack.
This is true. Again, but many times these are things you need to prototype and figure out how hard it's going to be to actually shake to where they're still putting tubes. When we watch video of the matches, you'll see how the tube placement actually works and things like that. And you'll see that it's pretty, as you're pushing a tube on, it's very difficult to move it out of the way once the tube's kind of touching it.
I had an idea where the robot would have a ramp on it, but instead of using it to get another robot on it, it would use it to get itself on another robot. Therefore, turning any robot that wasn't originally designed to let something on top of it. That's
Interesting idea. So one of the things we have to do, I'm using your idea for an example. It's a good idea because it could work very well. But there's always, you want to look at holes in ideas too, and that's one of the bigger things you have to be able to do quickly during the brainstorming process of figuring out what you're going to prototype and what design you're going to go to. So what would be wrong with necessarily building a robot to get onto other people's robots?
If they had like an open robot, if you try to drive on top of it, then you just crush all their electronics and maybe crush some of their stuff that's on them. Because you don't know what other robots are going to be like.
Right. Yeah, and that's one of the harder things you have to do, especially in games like this where you are interacting with your alliance partners, being able to design to what you think other robots are going to do, right? So basically your design would mean that somebody has to build a platform that's at about roughly the right height that's strong enough to hold your robot, right? How many teams are going to do that? Probably not too many. But there might be somebody, or if you could there's no rule against you talking to other teams, and like there's in other games they tried to like have a common spec for how teams would do something, where they had to do something together. So you could get on Chief Delphi or get on forums and say, okay, everybody build platforms that are like this because our robot can do this. How many people are actually going to follow that? I have no idea. That's up to you and how persuasive you are, but in theory it's possible.
We were thinking about having like an Omni wheel or something that like help with like getting pinned and things like that on our drivetrain.
Okay, so they bring up an idea it's used by several teams, but the basic idea is that if you have a standard, what everybody calls a tank drivetrain, where you have wheels kind of in line, you're driving only forward and backward. The wheels don't actually steer in relation to the robot, so you don't have any wheels like the front wheels of your car that actually steer. And the way you turn is by changing them at different speeds or putting them in different directions. So if you have your right side going forward and your left side going backwards, you turn left. But the problem with that is you get what's called scrub, is when you get pushed sideways, or when you're turning, some of your wheels basically have to be sliding sideways across the carpet, and they're not really designed for that. So what they were suggesting is you have some type of wheel that you drop down that gets rid of that sideways friction for the most part. You have rollers that are going that opposite direction, so that when you go to spin, you can spin very quickly. It's somewhat of an advanced technique. You can do it to get out of like people do. One of the things you'll see, if you probably did see if you went to off-season events, is what's called friction pinning, where you're in the middle of the field, but someone comes up and pushes you really hard sideways. And if you have a strong enough traction drive, you're not going to be able to move away from them because they're frictioned up against your bumpers. And it's one of the bigger problems and one of the big design things people are starting to do in terms of drivetrain design, is how to both cause those to happen, because you want to be able to stop the other team from doing anything, and prevent them from happening to you. So that happens a lot in drivetrain design. Other interesting things people were brainstorming: parts of the robot, claws, arms, lifts, anything?
I have an interesting 2012 design.
Not the game we're playing. If you said 2011, I might let you say it.
I mean the Frisbee.
Oh, that's 2013. Also not the game we're playing.
I would say something about our robot, which is very heavy.
One of the students who doesn't want to talk about it came up with an idea of grabbing the game piece. Instead of grabbing it from the outside, grab it from the inside. And one of the other students kind of built upon that and figured that that can be used as an alignment mechanism, so that when you push it on, it would align itself with the pen.
Yeah, and that's a very good, when we talk about teams that somebody's going to build it. I don't know if anyone built it in 2007, but I know somebody built it in 2011. And it worked very well for them. They won a couple regionals with it. Yeah. Team 16 Bomb Squad in 2011 built basically that exact design. And they grabbed all of those types of inner tubes. We're going to get to the 11 game after lunch. So how did people the people who were planning to hang tubes, how were we planning to grab tubes? Any?
A claw with rollers on it.
So we have one option for a claw with rollers on it. Other options for how to grab tubes? So you're grabbing it vertically, or which way? Oh, okay. Yeah, okay. So yeah, you just squeeze the inside and outside. Yeah. So so the design that they were just talking about, everybody, shh, we're talking again. Okay, so the design that they were talking about was you basically take a piece of metal and you have it on the outside, and you take another one that you stick on the inside and you close it across it, and then you're able to pick it up. That design happened quite a lot in 2007 and 2011. Team 118 actually built that claw design for both games. No, just one game. For 2007, that was the way their robot worked. So they had basically two pieces of square tube with traction material on it. They'd stick it down, squeeze just like that, and they were able to pick it up and manipulate the tube. What other types of claws can people build?
Not exactly a claw, but like, you know those things that pick up tennis balls? Kind of like that design. Just kind of like, it fits like this and kind of like...
Pick up all the way around it? Definitely possible. It's a little tricky to reach out that far if you have to grab the entire back end of the tube too, but teams definitely did it.
We're thinking sort of like what she was saying, but like you have one end that comes underneath and another one that just comes on top. clamps down.
Yeah, there are teams that do that too. So you basically have a spatula and then it's something that clamps on top of the spatula. Again, with anything that you can describe in terms of kitchen utensils or a string and a stick, anything that's very simple are going to be things that most of the time you can probably build. Even if you don't have access to really fancy tools or anything, you can build something that has two plates that close together in some way. Those are definitely things that are doable. Okay, other types of claw designs.
You proposed one idea where you use two kind of conveyor belts. So you could pull it in, and then if you ran them in different directions, you could turn the tube for manipulating it.
Yeah, so that's a design that's similar to what Abhishek was talking about, where you have a claw with rollers on it. In certain circles at first, most of the time when you're manipulating things, roller claw is always the answer. There's a reason for that, and basically that it's very, very easy. Most of the manipulators we have are motors. Motors like to spin things in circles. If you can do something by spinning something in a circle, you're halfway there already. So roller claws are basically something that goes up. It's about the right diameter. It has two spinning wheels that are spinning, and then it just sucks right into it. That works surprisingly well for most games. For a lot of game pieces, if you can just spin shafts, spin wheels, spin something against an object and collect it that way, it's very, very easy.
Design for your intake?
I mean, almost every intake this year was some version of a roller claw. But yeah, it would have to be much smaller to go around an inner tube. But yes, anything that has two opposing rollers or a flat thing and an opposing roller, there's lots of things that do that. It is extremely common, and when we start looking at the robots, you'll see that it's very, very common across most of the robots that they do things like that. Okay, where's my pizza guy? I don't know where my pizza guy is. Okay. So what are we looking at for lift designs? People said they were planning to make lifts. Did they have any way to thoughts on how to actually make the robots lift other robots, or how they were planning to use arms to get the tubes higher, anything like that?
We were just going to do ramps that had ramps, like mini ramps on it. That way it could drive up the ramp, but not back on.
Oh, okay. That took me a second. Okay, so you basically have a way you can chalk the wheels basically, so that once they're up, they can't roll backwards. There were quite a few teams who did something very similar to that, where they would have things that were able to fold down, and then as the robot drove up it pushed up a latch that caught it in the back, so then it stayed with it. So it would basically be like this, and it would push and then flip, and then it couldn't back up. Yeah, any ways that you could, that was actually a big challenge that a lot of people didn't realize, is if you built ramps, teams falling off your ramps was a big deal that a lot of people missed, where they would have really nice looking ramps, but then people couldn't either drive up them, or they would build things that were just like rails for a certain wheel width, but if your robot wasn't that width, you couldn't go up it. Like, it didn't have a middle section of the ramp.
Don't like about that the game from 2007 is that I don't know. It seems like it would be really hard to get pneumatics to bring a robot up on that ramp.
That is very true. Pneumatics would be very difficult. There are teams that were able to do it. You can calculate the forces and things, and there's a little bit of math involved. Pneumatic math actually isn't that bad. It's pretty simple area and pressure calculations, basically multiplication. But there were teams that were able to do it with pneumatics, but a lot of teams did it with springs. A lot of teams did it with gravity, other things that they could do, scissor lifts, and they did motors and winches and all sorts of ideas. Right, so like we can lift, you can go out right now to any car, pull a jack out of it, and you can lift a car up, right? Which weighs way more than a 120-pound robot, but you can pull part of a car up 12 inches pretty easily. So there's definitely ways to do that. And that's one of the big ideas, is figuring out where you can take things from other FRC robots, where you have to take things from real-world applications, and how you can actually get them in place to accomplish the game in the right amount of time and actually build it in 45 days and all of that. Okay. Oh, yeah.
One of the things we did, we actually did use pneumatics, and one of our elevating systems in order to get the higher levels on the rack was we used like smaller cylinders as you got higher, and we used pneumatics that would you would shoot it up and the pneumatics would come up, and then as you wanted to go to lower levels, you would like release it and it would drop different levels, and with that we would top it off with like a little claw that would articulate and allow us to get to collect like lower discs that were on the ground or something on different levels. So.
Okay. So they had the idea of having a telescoping pole that had various levels of pneumatic cylinders that would actuate to get to different heights, which is definitely doable. It's a little tricky because you end up using a lot of air, which you end up with air storage problems. But that was used to be more of an issue than it is nowadays. So just a little bit of a history lesson. A while ago in FRC, all the way into 2007, the robot rules were so strict that you could only have 4 small air tanks as your stored air. That rule went away in the last couple of years to where now you can pump on as many giant plastic air tanks as you want. And it makes pneumatics far more useful in that you can store way more air, you can do a lot more with it. Like none of the pneumatic catapults that we had this season would have been able to work 7 years ago when you had basically no air storage. And they were all metal air tanks too, so they were way heavier, so you didn't have, a lot of the trade-offs went away in the last few years to make pneumatics much more beneficial. And since we're building within this year's rules for this game, the pneumatics definitely could work.
We talked about some things. One was like a double jointed arm, where one joint is like the part that moves it for the various levels of the rack, and then the other is the joint for the claw that picks up the tube.
Right, so what he was mentioning is the other joint is the claw, so you have a...
Like this is the arm, you have one that like lifts the tube from the horizontal to the vertical.
Okay.
Like,
Yeah, no, I'm just... Oh yeah, but they have the pneumatic arm that year, right? Yeah.
Or like one for that.
Yeah, they were both pneumatic as the second joint, but those definitely work. 77, 2001. So to start looking at some robot pictures and getting you guys in the right frame of mind. Why doesn't Torque have a better picture of their robot? That one's decent. All right, so this is somewhat what down here you kind of see. They would have rollers, so when we're talking about roller claws, so these rollers right here are able to spin, and they suck in a tube, and then they're able to have a joint back here that actually flips this up and down, and then this is mounted on an arm that's able to move up and down as well. Let me see if I can pull. I have a whole thing on Raptor later, so I don't want to do Raptor right now. Who else does that? Okay, anybody else have lift or arm designs or any other thing that they thought up as a group? I feel like we're missing a lot of ideas that are just sitting on paper that we're not sharing. Oh yeah, sorry. Start over. My apologies, thank you.
If you had a separately built claw and you needed to roll that up and down, you could attach it to a belt on 2 40 pins, and when you use the rollers at the bottom, you could end up lifting it higher or making it go lower.
Oh, okay, yeah, like a chain bar. I don't have one off the top of my head. Yeah, no, that's a very good idea. That's used a lot in some of the smaller robotics competitions like Vex and things. You'll get robots that do that. Okay, other ideas?
An elevator.
How would that work?
Like, sort of like a forklift. You have like chain or belts and multiple levels of like kind of like a telescoping set, which the claw moves up and down on, and you can have 3 different set levels for each of the spiders.
Okay. Okay. Other ideas? We're really just killing time until pizza gets here. Watch robot rebuild videos. I mean, the whole point, we don't quite want to do that for 07 yet. We will if we have to, but...
Let's watch Einstein for 07.
I mean, that's...